I'm Professor Ed Gallier from the Fire Safety Engineering Group at the University of Greenwich, and I'm going to be giving this presentation on virtual and mixed reality training environments for first responders. The presentation I'm going to give is the result of a project that was run as part of the EU Horizon 2020 framework agreement. It's called Project AUGGMED. I've identified the team members from FSEC that were involved in the project. As you can see, there's quite a large team of people involved from our research group contributing to the developments, and I've also identified the partners on the project. So before we go into that, I'll give you a little bit of background as to who FSEC are. So we're a team of about 20 full-time researchers. We're fire engineers, CFD specialists, psychologists, mathematicians and software engineers, and our main research interests are in mathematical modelling and experimental analysis of evacuation dynamics in complex spaces, pedestrian dynamics in complex spaces, combustion, fire and smoke spread, fire suppression and security. And our application areas include the aviation world, the built environment, maritime applications and rail applications. And what I'm showing in these three animations, these three videos, are examples of some of our work. So we're involved in a lot of human behavior research to understand how people react and behave in all types of situations. And in the video I'm showing you here is some work we did for CP&I, looking at how people interact with security bollards during an evacuation. The second animation shows some work we've done using our evacuation modeling tool, Exodus, building Exodus. And here we're looking at the evacuation of a large high-rise office building in London. Using the evacuation model, we could identify problems with the existing evacuation procedures, and then using the model suggest ways to improve the efficiency of the evacuation so that the evacuation could take place in a shorter period of time and utilizing the exit capacity that we have in the building. The third animation is an example of our CFD model SmartFire, and in this particular simulation, what we're simulating is the release of a chemical agent on a station platform. This is an underground station in London, and we're looking at the release of a chemical warfare agent on the station platform, and how the piston effect of a train as they enter and leave the station helps disperse that product throughout the station. Okay, so these are three examples of the types of work that the Fire Safety Engineering Group are involved with. We've been developing our Exodus and SmartFire tools continuously since the 1990s. We have extensive validation history of these tools, and they're used in something like 35 countries around the world. One of the key features of our modeling tools is that you can couple them. You can take the output from SmartFire and couple it with the evacuation model so that you can see how the people react to the developing fire situation. The CFD code will calculate things like the smoke concentration, the visibility, toxic gas concentration, heat, radiated fluxes, and so on. And all of that's imposed on the evacuation simulation. And Exodus takes into account of these factors through fractional effective dose models. And so we can then run the evacuation and see how the evolving situation is affecting the people during the evacuation. So we can get a really good idea of how an evacuation would unfold in the presence of a fire or other types of hazards. So that in a nutshell gives you some idea of the sort of work that we do. I want to now move on to the main purpose of this presentation, which is talking about how we can use simulation and virtual reality and mixed reality to improve training of first responders. And what we're primarily concerned about in this project is how we can train first responders responding to a terrorist situation in a crowded place, usually the result of a marauding armed terrorist. We've seen a rise of these types of incidents around the world since the early 2000s. There's been a whole slew of them, and we know this is a real critical problem. I guess what the main issue is that we have soft targets like railway stations, office buildings, airport terminals that are relatively easy because of the number of people that pass through them to cause major problems with relative ease. Not very, you don't need a lot of sophistication to launch an attack on these types of crowded places. And so the question is, how do we train our first responders to respond to these types of situations where you might have hundreds, if not thousands of people exposed to the threat, and you have to go in there either as a armed tactical response team or as a firefighter or as a medical first responder and deal with the situation while you have a potential terrorist situation unfolding and you have all of these people trying to react and to respond. So training in these sorts of environments is very, very difficult, and we believe it's an ideal candidate for the use of virtual training environments. And that's the main thrust of this project. I should say that the key thing, if you're going to use a virtual environment, that the virtual environment has to be as realistic as possible. So what do we mean by virtual reality? And what do we mean by mixed reality? I'm trying to explain this using this simple diagram. On the one side, we have reality, which is the real world, and we have an image here of a passenger terminal in Greece. And on the other end of the extreme, we have a virtual world. This is a computer-generated representation of the space. And as you can see, the graphics looks very compelling. So this is a virtual world on the computer. And we have two ways we can interact with this virtual world. We have what we call an immersive environment, where you might put on a headset and you're immersed in the visual surrounding of the space. And we have the more traditional sense of being involved in the virtual world, where we see this just on a computer screen, and you can move around around the space using the keyboard and mouse. So we have an immersive and a non-immersive environment. And in addition to that, you can interact with the space in the virtual world, or you can be a passive viewer. So most virtual reality environments that we see, usually the outputs of computer simulation models, are usually non-interactive. You can just see what's going on around the space, but you can't interact with it. Okay, but you can create these spaces, virtual worlds, so that you can interact with those spaces. So they're the two ends of the virtual world. And in between the real world and the virtual world, we have what we call mixed reality. So we have a blending of the real world and the virtual world. And one example of mixed reality that we're all pretty familiar with is augmented reality. And in an augmented reality environment, what we do is we take a digital overlay, or a digital information, and we overlay it over an image of the real world. And this provides us with additional information as we move around in the real world. And an example of that is the reversing camera that we have in most cars. And what we impose a digital overlay on the video image from the camera, and that gives us guidance on how we can reverse out of a space. So that's a common example of augmented reality. But what we're particularly interested in this project is mixed reality. And in a mixed reality world, we have the real world and the virtual worlds are melded together so that the person is simultaneously immersed in the real world, but they're also in the virtual world. And so in the example I have here, we have an image of a real terminal, and on top of the image of the real terminal, we have the simulation taking place. And the person in using the mixed reality environment can interact with the real world and the virtual world and the simulation. So that's the beauty of the mixed reality environments. And what we're going to be talking about in this presentation is the virtual reality worlds, where we have immersive and non-immersive representations of that, and also the mixed reality environment. So what did we do on Project AUGGMED? Well, Project AUGGMED was really, the main thrust of this was to develop a virtual and mixed reality training environment for first responders responding to terror situations in crowded spaces. And what we did was we took the Unity 3D game engine And we removed from that the Hollywood style, if you like, representation of fires, of smoke, and of how people react and behave. And we replaced that with high fidelity engineering simulation tools. So for the people movement and the crowd behavior, we used the Exodus software to represent how the agents will be moving around and interacting. And we used the SmartFire CFD code to represent how fire and smoke spreads through a structure. We also, from one of our partners on Project AUGGMED, we had an explosion model, and we imposed the explosion model on the within the virtual world through Unity. Okay, so basically taking a well-known game engine and replacing the way it represents real-world effects with a high-quality engineering set of tools to provide more realism and better response to the evolving situation. Now, what we ended up with were 3 levels of tool. These are in a prototype form. We had what we call level 1, and in level 1, level 1 is an interactive VR environment. So as you can see in this diagram here, the real person interacts with the virtual world through a keyboard and mouse. And this is the simplest entry level into our system. And this means with this level of involvement, you can do this anywhere in your office. Anyone that's got a computer and access to the internet can interact with other people being trained in this virtual world. So it's a very simple way of introducing virtual training environment. And as I say, it can be just simply done on the desktop. Level 2 takes that concept and takes it a step further. And instead of just having non-immersive VR, we now have immersive VR. And as you can see in this picture, we have the person involved in the training is now wearing a headset and is immersed in the training environment, is immersed in the simulation environment. And on the screen there, you can see what he can see on his headset. Level 3 took it a step further, and it's our mixed reality training environment. In the mixed reality training environment, the person is in the actual place where they need to be trained. So it could be an airport terminal that they need to work in, or it could be a railway station, or it could be an office building. And when the person wears their headset, they can still see, it's just like they've got glasses on, they can see the real world, and so they can move around in this world, physically actually move, walk around the space, but in their vision, we impose the simulation, and they can interact with the simulation. Now, for level 2 and level 3, we also introduced a haptic vest, which added to the immersion and the feeling of actually being there. The haptic vest provided us with an ability to introduce touch and feel, and also thermal feedback. So, for example, security forces may need to communicate with each other by touch. So, wearing a glove and the vest, one person could virtually touch another person's shoulder, and they would feel that through the haptic vest. So you could have people training, say, one person training in London and one person training in New York, working together as a team, but they're actually miles apart. Okay, so using the virtual environment and adding to that the haptic feedback, you can have very, very good interaction between the players, even though they are not physically co-located. Okay, so that's the basic idea. These 3 levels is what we came up with. So what did we have to do to achieve this? Well, first of all, we had to be able to embed Exodus and SmartFire simulation tools into Unity and create a 2-way communication between the two. We enhanced our SmartFire output, so which usually outputs smoke information to Exodus as layers. What we did, we introduced multiple layers so that the visualization looked more realistic. And probably the most important and the most challenging part of what we did was we enabled an external user to take control of their avatar within the simulation software Exodus, so that the external person could control their avatar moving around in the space and interacting with the other simulated agents. Okay, so this was one of the main developments. Now, along with that, we had to introduce a whole heap of new behaviors into Exodus. So, for example, you may need to interact with other people in this sort of situation by voice commands. So, for example, a police officer may be asking people to stop, to move this way, to get down, to start to evacuate, and so on. So we had to create a vocabulary that could be used within the simulation, and so that the simulated agents would react to that. In addition to voice, there's also hand gestures. So the police officer may be putting his hands forward to indicating to stop, or to get down, or to move to the side. So we introduced hand gestures. We had to introduce a way to introduce firearms into the simulation, so that in Exodus, if a person aims at someone and takes a shot, we have to calculate the trajectory and whether or not they hit the target or not. And then we had to introduce ways of representing the injury, predicted injury from the gunshot and from explosions. And as part of the response of the crowd to threats, we had to introduce a concept where the agent would react to the threat posed by the terrorist. We introduced the concept of awareness and threat zones, so that the simulated agents could react in some way to the threat posed by a terrorist, the physical threat posed by a terrorist. And we introduced behaviours such as flee and take cover. Okay, and I'll talk a little bit about those later on. So this is an example of what it looks like. So all of the agents that you see moving around are controlled by Exodus. We're in the Unity environment here. We're moving around this airport terminal, and the view you're seeing is the third-party view of the person that's being controlled, the avatar that's being controlled by a real person. So this person is moving around, and you're seeing what he sees as he moves around the airport terminal. We have a fire in the airport terminal. Now the fire is being simulated using smart fire. The smoke that you see is being generated by the CFD simulation, and in addition, there is also the heat, the toxic gases, the radiative fluxes, and the toxic gases that are produced by the fire, and they're being distributed throughout the space, reacting with the ventilation system and so on, and we simulate all of that with our CFD simulation. So we get a realistic representation of what's going on in terms of the fire generation within that space. So the people that are being trained have something realistic to respond to. I mentioned the hand gestures and the voice commands. What I'm going to show you here is a real person. We've got a third-person view again from the real person in the simulation, and he's going to issue a voice command and hand gestures to these simulated agents, asking them to stop, telling them to stop. And we'll hear that, and we'll see what happens.
Stop!
So he's calling out stop, and he's raising his hand, and some of the agents have responded. You see this guy at the back didn't quite respond to it. He kept on going, so he needed another command. Those other people you just saw coming in, they were around the corner, so they didn't hear or see the police officer, and so they kept on coming until he issued the second command. So we introduced a whole range of vocabulary, simple commands such as stop, go, get down, evacuate, and that sort of thing into the simulation environment. I mentioned the way the simulated agents react to the threat. One of the things we introduced is what we call the threat zone. So the threat zone is a region of space around the terrorist. An agent, a simulated agent inside the threat zone, will try and escape from the threat as easily and as quickly as possible. And so we take into account the direction in which the agent was originally moving, and we have a vector which, if you like, is a repulsive force that drives the person away from the terrorist, and then we have the resulting red vector, which is the resulting direction of movement. Now, when a simulated agent is inside the threat zone of a terrorist, they will try to leave as quickly as they can without even considering where the exits are. They just want to get away from the vicinity of the threat. We also have the awareness radius. So this is outside the threat radius, so that the simulated agents are aware that there is a threat, and they are aware that they have to leave the space as quickly as possible. And so in the awareness radius, the agents try to find the quickest way to an exit to get out. And they will discount routes to exits that take them through the threat zone of the hazard. Okay, so they try and find, if they're in the awareness zone, they actually try and find the quickest way out that keeps them as far away from the threat as possible. So that's part of the complex behavior that's within the modified version of Exodus. What I'm going to show you here is this is a level 2 view. So this is a level 2 system. So as you can see, the person, this is Darren, one of our team members, he's wearing the immersive headset. And what you see on the screen here on the left is what he sees in his headset. What you see on the screen on the right is what the trainer sees. So this is the overall perspective of what's going on. Now, Darren is representing a terrorist. He has 2 hand controllers, one that's going to move him through the physical space, and the other hand controller, it represents his weapon. And the threat zone is indicated by this red circle, and the awareness zone is indicated by this yellow circle. And as he moves, you'll see the threat and awareness region moves, and also as he fires his weapon, the threat and awareness region expands. It expands because people are now more aware, because they can hear the gunshots, maybe not directly see it, but they can hear the gunshots. And as he's firing, his threat region also expands. So we'll just play that. So you can see he's looking around the space, and now he's taking aim and he's firing at people, and you can see the zones changing in size as he fires and moves around, and you can see also the simulated agents responding to the threat and trying to escape. Okay. So this is now level 1 in the software. The red flagged agent is the agent that Darren is controlling, and what Darren sees on his screen is what his avatar is looking at, and he controls the movement of his agent using a keyboard and mouse. He can direct him and move him around, and he can interact with the other agents. So as you can see here, he's approaching the security area. You can see on the screen, and you can also see it in the big world picture as well. And in the big world picture, you see he's approaching this doorway, which is the doorway here. He passes through security. He's going through the security check. You can see that through here. And then he arrives airside in the airport, and he's turning around to have a look around, and he decides to walk towards the shopping area in the terminal building. So Darren is controlling his avatar in the simulation with a keyboard and mouse. You'll notice this icon here. There's also a radio contact, so the players in the simulation can contact other players that are remote from them by radio, or the outside incident commander can contact the players who are representing the security forces also by radio, providing them with additional information. So in this view, we're seeing the view from one of the security people, and these are now being played by real security people. So here we have 2 armed tactical response team members. They're trying to find the terrorist. The bomb has gone off in the airport terminal. There's a fire developing. This is the terrorist. They identify the terrorist through the radio contact where they've been told what he looks like, what clothing he's wearing, and you can see they're tracking down and chasing the terrorist. Now the terrorist is played by a real person as well, So there are three people interacting here. Okay, so the terrorist was played by a real person controlling his actions, and the two security force guys were also being controlled by real people controlling what they're doing, trying to track down the assailant. And they had to deal with the crowd, the noise in the airport, the smoke developing from the fire generated by the explosion, and all of that has been simulated using our simulation environment. So it provides a realistic, as realistic as we can, feedback as to what's going on. Now, one of these level 1 test cases, we had 10 participants, and we asked them a range of questions to see how realistically they felt the environment was. So we asked the questions, for example, how realistic did you think the simulation was? How realistic do you think the agents evacuating the building and their behavior was? How realistic do you think the agents responded to your commands, your gestures and your voice commands? Did the agents, how realistically do you think the crowd moved around and navigated, and your movement around and navigation? How credible was the agent behavior in response to your command, in response to the smoke environment, and in the non-smoke environment? And here in these in this bar graph, you see the responses. Now the responses were either the Likert scale from very realistic to not realistic at all. And the really good thing is that most of the participants thought that to answer most of these questions was that at least 90% of the participants thought it was realistic or very realistic, which is quite good, because this is, remember, this is level 1, and so this is not where they've got the immersive environment, it's where they're wearing the headset and interacting with the keyboard. It was interesting that one of the participants made a complaint that the simulated agents didn't respond immediately to his commands, so he had to issue several commands. In fact, that's a good thing, because that's how people would actually react in the real situation. They're not necessarily going to react immediately to your command. Okay, and so the fact that he noted that, and he was actually quite annoyed by that, is actually a positive thing, because it's giving some positive feedback about how people would react potentially react in a real situation. One of the things that was probably that the candidates, the participants found least satisfactory, was the use of the keyboard and mouse to interact with the environment. Even so, even though this had the lowest satisfaction score, 70% of the participants agreed that the keyboard or mouse controls were intuitive and easy to use. So it was easy to use, but it was perhaps it broke that sense of immersion. Okay, and so this is why we moved to level 2 to improve that level of immersion. Now in level 2, what we've used is a headset, and in this particular project we used the Hive, the HTC Hive headset, and this the players then have 2 hand controllers. One that's going to control their movement through the space. So with a trigger, they can control the speed and the direction in which they're moving. And with the other hand controller, they can operate various devices. For example, they can operate a weapon, or they can use it to tag people in a medical response, for example, to tag in triage. And they can also use the hand controller to issue the voice commands or the hand gestures. And we also have these beacons, and the beacons are used to monitor orientation, if the person is bending down, if they're turning their head. So these beacons identify that in the VR environment, the level 2 environment. In the mixed reality environment, which we'll talk about in a few minutes, the level 3 environment, the beacons also allow the people to physically move in space. So in the mixed reality environment, they don't need the hand controller to move in space. They actually physically walk in the space, and the beacons track that movement. So that's in level 3. Okay? But in level 2, the beacons are only used to track orientation. Am I crouching? Am I standing? And my orientation, left, right, and turning around, and so on. So in this slide, what I'm showing is a walk through the virtual world using the immersive headset. So this is what the person sees in their headset as they're walking around in the environment. Now remember, walking around the virtual environment, he's using a hand controller to manage his movements. And these images on the right are real photographs from this space. And what I hope this convinces you of is that the virtual world looks pretty close to the actual real world. So we're getting a pretty good representation of what's going on. So here is an example of the virtual world in using the immersive headset. We're going to have Peter demonstrating the headset. What you see in the image on the screen on the left is what he sees in his headset, and what you see on the image on the right, on the screen on the right, is what the trainer sees. Okay, so the image on the left, the screen on the left, is what Peter will see in his headset. And so there's an incident in the airport.
Sound the alarm.
Bombs going off. There's a fire, and people are starting to evacuate. And voice alarms sound. But you'll notice that some of the airport staff have not started to evacuate. They've remained in their workstations. And so what Peter is doing is walking around and he's ordered them to start to evacuate. So he's issued a voice command telling them to evacuate. And then the simulated agents respond to the authority figure, and now they start to evacuate. In this view, it's a little bit further on, we're looking now as the fire develops. You can see the smoke in the tube. Remember, this is what people are seeing in his headset, and you can see here in the bird's eye view, the smoke is on the land side, and we can see Peter wants to look under, so he's actually crouching down, and you can see the view has changed. This is the beacons monitoring that and change the view in his headset. And he's now looking around, looks up at the smoke, and you can see. Now, also, we're calculating in this simulation the effect of the toxic gases on the trainee. So he's inhaling toxic gases, and we're calculating the fractional effective dose of this as the person moves around. So eventually, if he doesn't get out of the space quickly enough, he's going to become incapacitated by the toxic products. And so this is a good learning experience for the trainee, so that they understand the impact of being unprotected in this type of smoky environment. This is another example of level 2, and here we're doing a medical example, and we have these two medical first responders, these guys in yellow. There's a bomb going off in an underground station in Barcelona, and their job is to get to the most seriously injured people and do a triage. Now, as part of their training, they're meant to ignore the walking wounded and get to the seat of the problem as quickly as possible and do a triage on the most seriously injured. And what we're going to see on the screen, so this is now shifted to the headset view. So this is what one of the medical first responders, so you can see his colleague just in front of him, and now they're walking down the platform. They're ignoring the walking wounded, and they're going to the seat of the explosion where most of the most seriously injured people are. As they're meant to do, they're ignoring the walking wounded. They've got to make their way to the most seriously injured people. And when they get to the most seriously injured people, then they can start doing the triage process. And what we see here in this second video is these people in yellow, the actual first responders. So these are the actual medical first responders from Barcelona, and they've now reached the seat of the explosion, and they're now undertaking the triage process. So you can see this lady's crouched down, checking out one of the victims, and deciding what level of condition she needs to tag the person with. Okay, so it's quite a realistic environment, and the trainer can see what's going on his screen and interact with the trainees. This is another example of level 2. This is now one of the Greek Special Forces guys who's trying out the system. So he's hunting down a terrorist in the terminal building. So you can see he's wearing the headset. The beacons are measuring what he's crouching down. and his orientation of his headset. And you can see he's crouching, trying to come around this corner to see if the terrorist is located around there with his weapon drawn. So he's actually fully immersed in this environment, and he's taking it quite realistically, and he's practicing his doctrine. He's demonstrating that he understands the way he should be reacting and behaving as he's been trained in this environment, and he's reacting to the simulation as it unfolds. Okay, so from there we move on to level 3. Level 3 is the mixed reality environment. Now, in the mixed reality environment, the headset is meant to be like a pair of glasses that you can see through, and you can see the actual space, that you're in the real space, but we impose the simulation. Now, when we started the project, we were going to use the HoloLens 1, but we found the HoloLens 1 was not really up to the job. It had a very narrow field of view, 34 degrees, which was not representative of real peripheral vision, so we decided not to use that. But even with HoloLens 2, even though it's got a much better field of view, 52 degrees, that still doesn't represent a realistic representation of the field of view, so it's still quite limited. The other disadvantage of using the HoloLens, which is still an issue with HoloLens 2, is that the imposed simulation, the avatars, are semi-transparent. And because they're semi-transparent, it breaks the sense of immersion. So we decided not to use that, and we came up with a Heath Robinson fix to the problem, and we attached, as you can see in this picture, we attached a video camera to the HTC, the Hive headset, and the video camera recorded what was happening in the real world, the space that the person's in, and it transferred those images to the headset. So in the headset, you're seeing an image from the camera of the real space. Okay, and as I said previously, the beacons are now measuring the translations. Your movement in that space are being recorded by the beacons and reflected in the simulation, as well as you physically moving in the real world. Your physical movements in the real world are transposed to the simulated world because of due to the beacons. Here we can see the person wearing the mixed reality headset, and on this computer screen you can see what he can see in his headset. Now he's in the real passenger terminal. You can see it. He's in the real terminal. You can see the real terminal here, but imposed on that is the simulation, and you can see hundreds of agents queuing up, walking around the terminal. As he turns around, he looks down into the terminal, and he sees lots of people in the terminal. Now, in reality, there's nobody there. Okay, but so that's part of the simulation. Now, he can interact with that simulation, with that simulated environment, and get the agents to respond to his commands. So what I'm showing you here now, again, this is the view from the person wearing the headset. So he's now wearing the headset. He's in the passenger terminal. He can see all these people. Now, in this particular scenario, the person wearing the headset is actually a terrorist, but he's dressed as a police officer. So he's giving commands as a police officer to the crowd, and the crowd respond to that because they think he's a police officer. Also, we're just going to, it's somewhat hypothetical, we're just demonstrating the capabilities of the simulation. So here we have the people moving around the terminal. This is what the person wearing the headset is seeing. There's actually nobody there. He's looking around, he's moving around the terminal. He's physically in the terminal and moving around, and he can see all these people. Now, he's going to issue a command. So he's told them to stop. You can see his real hand coming up. And now he's told them to go on. And they start to move. People far away can't hear the command, and so they keep on moving. So these guys stop. They've heard the command. Not everyone does. And now he's told them to go on. So remember, he's a police officer, and they're doing what they're told. Now he gets them to stop. He's looking around again, making sure these people are stopped. And now he decides to open fire. He raises his weapon, he starts shooting, and now the people react and start to evacuate. These people can't move anywhere. They're up against a barrier. They're crouching to try and reduce their profile, and eventually they start to evacuate. So this is a real person in a real space, moving around the real space and interacting with the simulated people. Okay, so to conclude then, virtual and mixed reality training environments provide a means to improve realism in training. It enables the creation of training scenarios that would otherwise not be possible or viable. For example, involving large crowds with fires and explosions. The virtual environment allows realistic training to take place anywhere. So using the keyboard and mouse, or even using the headset, you can undertake that training in your office, at your home. You could train with another person who is located in a different space using the VR environment. The mixed reality environment allows realistic training to take place in the actual target facility. So not only are you practicing your doctrine, not only are you practicing your procedures, you're actually in the real space, so you're experiencing the real space. However, it's really important that to ensure a quality training experience, it's essential that the simulated environment scenario responds in a realistic rather than theatrically in a theatrical manner. And that's why it's essential to utilize validated engineering quality simulation tools to control the behavior of the crowds and also the physical behavior of the fire, the smoke, the toxic gas, and the explosion, and so on. So the use of engineering quality modeling tools in conjunction with good data enable the immersion to be maintained, enhancing the training experience. These VR and MR training environments can also be used not only for training, but to help you to develop and test your proposed mitigation strategies. So you can use this as a sort of lab to try out your procedures to see if they've got a chance of working. My final slide on this is, so what are the potential training applications? Well, we believe that these sorts of environments can reduce the need or the frequency of actual full-scale evacuation drills. It doesn't replace them. You should still be doing real full-scale evacuation drills, but using this type of environment, you can reduce the number of drills, actual physical drills that you need to do. It can provide evacuation training tailored to your building while you're seated at your desk in your office or at any time. You could be at home and you're undertaking an evacuation drill of your office building. So there's a whole range of applications where you could use this for evacuation training. High-rise office buildings, high-rise residential buildings, financial centres. You can't evacuate people on the trading floor. It's very difficult to find the time to do that because every second counts in terms of their trading. So using a virtual training environment is one way of addressing problems associated with financial centres. But other environments like hospitals, airport terminals, railway stations, offshore facilities where you can't necessarily have a downtime because of evacuation training, this is one way you can introduce that. But remember, the key thing is it doesn't replace the need to do that. It just hopefully reduces the need for the frequency of those sorts of events. Staff don't even have to be on site. As I said, you could train somebody in the evacuation procedures prior to them joining a new facility. And it can provide specialist training for managing large-scale evacuations, for example, aircraft cabin crew. How can you manage the evacuation of 200-300 people on an aircraft that's on fire? You can use this to help train crew on cruise ships and passenger ferries, train crews, passenger train crews, and facility managers can use it to help them develop their procedures and train their procedures for managing large-scale evacuations. And obviously, it provides specialist training for managing incidents associated with terrorism that may occur, as we've tried to demonstrate in this presentation. If you're interested in exploring these training opportunities, please do get in touch with me. I'm Professor Ed Gallia, and you have my email address. While I've got your attention, I just wanted to identify two other security-related developments that we've been working on. One is a version of Exodus we call MAT Exodus, and MAT Exodus stands for Marauding Armed Terrorist. So rather than having real people take the role of the terrorist, as we've just been discussing, we have a simulated environment. So it's running within the Exodus software, the actual terrorist behavior. And in this animation, what I'm showing you is the terrorist moving around and interacting with the crowd. So this is all now a simulation. So we've built in some intelligence into the terrorist movement. He's hunting down targets and he's opening fire on the targets. The cone that you see is what we call his shooting cone. So this is the area in which he can target people. And he's hunting around for targets. and the simulated crowd is responding to the threat. So they're all trying to get away from the terrorists. And you can see he's now closing in on this group, and some of the agents will break away and try and move away from the threat. Okay, so that's MAT Exodus. So it's a simulation environment we've been developing to simulate the impact of a marauding armed terrorist in a crowded place. This is with the support of the DSTL. So this is a research project with DSTL. The very last slide I want to show you is some work we've been doing on COVID-19. And here we've modified the SmartFire software to simulate the release of respiratory aerosols, aerosol droplets. And here you can see a passenger train environment where we have two people, one seated by the window and one seated on the aisle, and they're infected with COVID-19, and we're looking at the respiratory droplets and how they are dispersed in the space given the ventilation. So we have the air coming in at the top and being taken out at the bottom, and being recirculated. So there's also recirculated aerosols being pumped back into the environment. But using this sort of tool, we can identify, for example, hazardous locations, the impact of physical distance, and how the droplets may spread and disperse as a result of the ventilation system. In this animation here, this is again a SmartFire simulation, and here we have an infected person walking around a supermarket, and he's with each of his breaths, he's releasing aerosols containing the COVID virus, and we're looking at how this spreads through the supermarket, how the aerosol droplets spread. Okay, now this is just simply a moving source of aerosol without taking into account the wake effect caused by the moving person. In this animation at the bottom here, we've got 4 people walking in a row here and 4 people approaching, and the person in the front here is releasing infected respiratory aerosols. And we're looking at how the wake effect of the turbulent wake effect caused by the movement of the people is dispersing the droplets. Now, each of those people are 2 meters apart, but as you can see, the droplets are spreading well beyond the 2 meter distance due to the effect of the wake effect. And also these people that were approaching have also had an effect on the distribution of droplets, but in a positive sense. So they're pulling droplets away from these agents that are following the person in the lead. And this last animation here is an example of Exodus, where we've imposed physical distancing. So now the agents are trying to keep 2 meters apart. We don't force agents to keep 2 meters apart because that's very unrealistic. While people might try to keep 2 meters apart, they don't always succeed. And in this simulation, we have the agents moving through the space, attempting to maintain a 2 meter separation. And where these, each circle is a meter radius circle. So where the circles overlap, it indicates that the agents are closer than 2 meters. And within Exodus, we calculate the degree of overlap, how close they are coming to each other. We measure the duration of the close contact, and then we calculate a proximity dose. So for a given simulation, we can calculate the impact of that circulation environment, the movement through the space, and how close people have come together. So you can use this sort of simulation tool to help you manage your throughput. How can you maximize your throughput through the space? How can you maximize your occupancy while maintaining, while minimizing the proximity dose? And we also come up with a critical proximity dose, which is based on the being 2 meters apart, closer than 2 meters apart for more than 15 minutes. We can calculate a critical dose, and that again can also give you some very valuable information. Thank you very much for your time. I'll be happy to take any questions.